Oh, what are we gonna do today? We are going to be invited to the Johnson Kendro Video Hour.
But it's not an hour.
And I know you wish it was. All right, we're doing the second part of these parabolas because there's lots and lots to do. All right, we're going to talk about standard form to vertex form. That's what SF and VF stand for. We have steps over here on the right. First, find the vertex. That's your H and K. Then use the same A as you did before and rewrite it in this form. Just putting in H and K. Now, how do you find the vertex? Remember our little tiny formula? Miss Johnson, you remember that little cute formula we had?
X equals negative B over 2A.
Yeah, that's the cutest formula I've ever seen. So negative B, remember this is A, B, and C. So negative B would be positive 6, opposite of B. 2A would be positive 6, so we have 1. That's the first part of our vertex. Plug that back in, right underneath here, and that will help us, whoops, minus 3, that will help us find our Y. So 3 times 1 squared is 3, minus 6, minus 3. I get negative 3 minus 3, so we're talking negative 6. All right, so that's our H, that's our K. Use the same A as we did before. So 3x minus H, which is 1, and then plus K, but our K is negative, so I'm going to say minus 6. And then don't forget your little square because it is a quadratic. All right, let's look at the next problem. And here we are. We are going to see where C looks. I think I see something here that I need to do. I think that's kind of cool. All right, now back to the task at hand. All right, so we're going to use the C, this right here, to help us graph quickly. Because mathematicians are lazy at heart.
That's the same equation you just did, isn't it?
Yeah, so that's going to save us a little bit of time. Do you remember the vertex?
I think it was 1, negative 6.
There it is, 1, negative 6. So my vertex is 1, negative 6. So I'm going to plot that. 1, 2, 3, 4, 5, 6 right there. And then this 3 is our C, and that's actually the y-intercept.
Oh.
So on the y-axis, I'm going to go down 3. And that's going to be part of our vertex. Now the cool thing is, to graph it quickly, all we do is reflect to this other point, and that makes our beautiful curved parabola.
Wow, that was fast.
It's very fast. That's what's nice about y-intercepts. Oops. All right, let's try this one. Find the y-intercept. Well, it's not just this last number. You have to work this out to get it in the other form.
How do you know that's not the last number? It's not negative 2?
No, because it's not in the right form. We have to get it in the ax squared plus bx plus c form because it's the C. Y-intercept is the C.
And we have vertex.
Right, this is H and K. So what we're going to do here is we're going to have to FOIL this out to expand it and then see where C ends up.
See the C.
See the C. So 3, then I have x plus 1. Because it's squared, I'm going to write it twice. And then I'm going to do my foiling. So x times x, x times 1 times x, and 1 times 1. Rewrite the rest. Thank you very much. Now we have 3. I'm going to just put those two together. X squared plus 2x plus 1. And then distribute the 3 to everything. 3x squared plus 6x plus 3 minus 2. Now you see that these two can go together.
I see.
Do you see? That gets us our C. It's a new C. So there is the y-intercept. And you can call it 0, 1, if you please.
C. I see.
Sweet. have to do the intercept, I'm sorry, the vertex with the intercept. So we want to sketch this parabola. This is going to be pretty quick. Just go to your vertex, 1, 2, 3, 4, and then down 7. 1, 2, 3, 4, 5, 6, 7. There's 4, -7, and we have a y-intercept at 1, so put a dot there. Remember, it's a reflection. So if I go up and over the same amount, it's going to be right here.
Oh, that's because it's symmetrical, huh?
Right, there's that axis of symmetry. So then you can just draw in your beautiful sketch going through those and have a quick picture.
All right, let's do another one of those.
Those are fun.
Quick. Oops. I deleted the wrong thing. There we go.
All right. Okay, here's the vertex. -2, 0 is here. Now keep in mind that's the vertex, so that's either the high or low point. So then we have -1, -3 is down here. So that vertex now becomes the high point. So if I just reflect another point to equal that -1, -3, I have my beautiful graph one more time. All right.
Looks
So those,
good.
yeah, those aren't so bad. They're kind of fun.
All right, now the word problems, which is where the real fun comes in. So here's the cool part about word problems in Chapter 4. We're going to be talking about quadratics all the time, and we're always going to be maximizing or minimizing. And Mrs. Kenderlis talked about the high point or the low point. If you have a high point or a low point of your parabola, it's always happening at the vertex. So we're going to be looking for values of the vertex. So no matter what they're asking, eventually we're supposed to be finding the vertex.
All right.
All right, so here's our first example. It says the equation h equals -16t squared plus 32t plus 9 gives the height of a ball, which we're calling h, it's the same as our y, just like y, in feet above the ground at t seconds, that's like x, after the ball is thrown. So what's happening is this guy's throwing it, and then we're making a graph of its height after a certain amount of time, and if you were to do that, it would look like this, okay? So how many seconds after the ball is thrown will it reach its maximum height? Well, that's happening right here. That's the vertex. And the coordinates would be x and y, and remember we're using t and h in this example. So how many seconds after the ball is thrown will it reach the maximum? We're supposed to be finding the t coordinate, which remember is the same as the x coordinate. And we're going to use that cute little formula, opposite of b over 2a. Our b is 32, so -32 on the top, over 2 times a, which is -16. We're going to get -32 over -32, and that's 1. So 1 second, that's how long it takes for it to reach the top.
Wow, that's pretty fast.
It is pretty fast. And then this is asking for the maximum height. That's asking for an h value or the y value of the vertex. So to find that, all we're going to do is substitute the t value that we just came up with. So -16 times 1 squared plus 32 times 1 plus 9. We'll get -16 plus 32 plus 9. I think we end up with 25 feet.
Wow, got quite an arm.
Yeah.
Throw the ball 25
Maybe it's
feet
because
up.
he's laying on the ground.
Maybe.
Yeah, maybe that's the key. All right, one more question. So the village of Spring Lake is planning to build a new dog park. They need to put a fence to enclose the space. What is the greatest area? That's going to be key if they are using an existing wall and 200 feet of donated fencing. So I've got my pretty little diagram here.
Those are cute dogs.
Thanks.
Do you have a dog?
I don't have a dog.
I have a dog.
Would you take him to the dog park?
Yes.
That's
He's
good.
very friendly.
Good. Good. And cats.
Too friendly.
Hey, that's okay. All right, so that dotted line that we have there represents the fence, and we do not know how big to make it, but we know that we want to maximize the area. So if we were just to pick a length, we're going to use x to represent that length on that one side, and since it's a rectangle, we're going to use x on the other side as well. And remember, we have 200 total feet of fencing. So if I've got 200 and I'm going to use this side to represent x and this side to represent x, if I wanted to find the ending side here, I would have to subtract 2x for that to tell me the length of that side. Okay? Now, I want to find the area, and this thing is a rectangle.
How come you don't use the right side of the rectangle?
Oh, well, because this is an existing building, so this building is already here.
Oh, dogs can't jump over the building.
That's right, so we don't need a fence on that side.
Phew, okay.
Okay, so area of a rectangle. Mrs. Kendra, do you know how to find area of a rectangle?
Yep.
What are you gonna do?
Length times width.
Length times width. Good. So my length, we're using the length x, and I'm gonna multiply it by the width, which is 200 minus 2x. So I'm just taking the size and multiplying them together. That's 200, not a 206. To find that area, I am going to distribute. So I would get y equals 200x, and then this is going to turn to minus 2x squared. I'm going to rewrite that in standard form, so I'll put the x squared stuff first. And there's my equation. This represents the area of our dog park. So remember, we want to maximize the area.
That kind of looks like a quadratic.
It does look like a quadratic. And if we want to find the maximum, remember, this has a minus negative a value, so that would be upside down. Therefore, the maximum is just going to happen at the vertex. So let's find the x value of the vertex.
Cute formula. Cute formula.
Negative b over 2a is what we want, that cute formula. Negative 200 over 2 times negative 2. That's going to be negative 200 on the top over negative 4, and we'll get 50. So 50 represents the x. But remember, I want the area, and the area is my y. So we will take that 50 and we'll plug it back in. I've got negative 2 times 50 squared, and then I'm going to add 200 times 50. Okay, so using my order of operations here, we'll have to square the 50 first, and then multiply it by negative 2, and we'll get negative 5,000 if I do that.
Good math skills.
Thank you.
Mental math.
And then, this is easy. I just ignore the zeros. I do 2 times 5, that's 10, and then I put the zeros back on.
All right.
Then we add those together, and we get 5,000. So that represents our area. 5,000 feet is the maximum.
Feet squared for area?
Feet squared, thank you.
Yeah.
Because it's area.
That's a pretty big area. I wonder how many dogs could fit in there.
I don't know, maybe more than 4 dachshunds.
Yeah. Little dachshunds. Gotta love them.
All right.
All right. Ta-ta for now.
See you guys.